Okay, so 16 books and rupees 120 is the actual price of each book. We have understood. Question number 20. So in question number 21, question number 21 has been told that in the adjoining figure, the adjoining figure the adjoining figure AB is perpendicular to BD, PQ is perpendicular to BD, and CD is perpendicular to BD. AB equal to X units, BD equal to X units, CD equal to Y units, and PQ equals to Z units. Then prove that one by X plus one by Y equals to one by Z. So here this is ABD. So C, this point is P, this is Q, this is X, this is Y, this is Y, this is Z. We have to prove that 1 by X plus 1 by Y is equal to 1 by Z. And it is told that AB is X units, PQ is units. So here AB is told AB is perpendicular to BD. AB is perpendicular to BD, so it means that, and PQ is also perpendicular to BD, CD is also perpendicular to BD, so it means that I can say, therefore AB is parallel to PQ, which is parallel to CD. Since why? Since here we can see that the corresponding angles are equal, and here also if we can say that since the co-interior angles are supplementary, since we add these two, we get 180 degree. So PQ is also parallel to CD. So now here, if we take the length PQ as A units, QD as B units, So now one by, so we can see that in triangle DAB, PQ is parallel to AB. PQ is parallel to AB. So I can say that um, so now I can say that triangle PQD is similar to triangle ABD by angle similar. Since why angle PDQ is the common angle, PDQ is equal to angle ADB, and these two angles are equal. So by angle rule of similarity, angle similarity criterion, angle similarity criterion, triangle PQD is similar to triangle ADB. So I can say that PQ by AB is equal to QB by BD. So here we do that, let's say we took BQ is equal to A units and QB is equal to B units. So therefore BD is equal to BQ plus QD. So I can say that that will be A plus B units. A plus B units. So now PQ by AB, PQ by AB, PQ is Z, AB is X. That means QB that is equal to A by BD that is equal to A plus B. So now, and similarly, we can say that in triangle BCD, uh, PQ is parallel to CD. PQ is parallel to CD. So now, triangle EBQ similar to triangle CBD by angle similarity, by angle similarity criteria. Since why this angle is common, I can say angle PBQ is equal to angle CBD, which is the common angle, and these two angles are right angles. Angle PQB and angle CDB. So therefore, I can say that some problem with the screen. Okay, fine. So I can say, so I can say that PQ by CD, PQ by CD, that is equal to PQ by PD. Sorry, here there is something wrong. Here PQ by AB should be equal to QD by BD. QD by BD. So this will be B by A plus B. B by A plus B. And this is PQ by CB. PQ by CD, that is equal to BQ by BD. So now, therefore PQ, that is Z, Z by CD, that is equal to Y, will be equal to BQ, BQ that is equal to A by A plus B. So now, Z by X plus Z by Y, that will be equal to B by A plus B plus A by A plus B. So it means I can say Z by X plus Z by Y. That will be equal to, if I take the LCM here, that will be A plus B. And here also it will be A plus B. So A plus B by A plus B, that will cancel out. That is equal to 1. So I can say Z by X plus 1 plus Z by Y, that is equal to 1. So if I take Z as common, then I can say Z into 1 by X plus 1 by Y, that is equal to 1. Which means that 1 by X plus 1 by Y equals to 1 by Z. So hence proven. And question number 22. Number 22 is given that in the figure, the adjoining figure, triangle CAB is a right triangle. Triangle CAB is a right triangle. Is right angled at A. Is right angled at A. And AD is perpendicular to BC. Then prove that triangle ADB is similar to triangle CDA. Then further, if BC equals to 10 centimeter, and CD equals to 2 centimeters, find the length of AD. So in the figure is like this. CAB, this is AD. This is the right angle. So AD is perpendicular to BC. Prove that triangle ADB is similar to triangle CDA. Further, if BC is 10 centimeter, CD is 2 centimeter, then find the length of AD. length of AD I have to find out. And the length of AD. ADB, and we have to take CDF. Now with this angle, if I take x, this angle will be obviously 90 minus x, since y, this is a right angle. So I can say since the proof will be like this, since y, since we know that angle A plus angle B plus angle C, that should be equal to 180 degrees, since by using the angle sum property, of a triangle. So now angle A, that is 90 degree, plus angle B, if I take x, so we take, let's suppose angle B is equal to x degree. So I can say x degree plus angle C, that is equal to 180 degrees. So if we solve it, then we get angle C is 90 degree minus x. So this angle, now this triangle is also a right angle, a right triangle, triangle ACT. Now, if this is 90 minus x, similarly, this should be x. And similarly, in triangle ABD, this is a right angle. So this is x. So this angle will be 90 minus x. So now it means I can say that in triangle ADB and triangle CDA, angle ADB, that is equal to angle CDA, that is equal to 90 degree. It is given only since AD is perpendicular to AC. And also we can see that angle ABD, that is equal to angle CAD, since both are x degrees. And also we can say that and angle ACT, that is equal to angle EAT, is equal to 90 minus 60. So I can say that triangle ATG is similar to triangle CDA by angle rule of similarity, or AAA similarity criterion. Right. Angle similarity criterion. Now, further, if BC is equal to 10 centimeter, BC is 10 centimeter, CD is 2 centimeter, the length of AT. So from here we can say that therefore I can say AD by CD, that is equal to AB by CA, is equal to DB by D. Since why? The reason is that since the corresponding sides of similar triangles are proportional, is the corresponding sides similar triangles, corresponding sides of similar triangles are proportional. Corresponding sides of similar triangles are proportional. Corresponding sides of similar triangles are proportional. So AD. So from here I can say that AD by CD, that is equal to BD by AD. So from here AD we have to find out AD by CD. CD has been told AD by CD. So AD by CD. So CD has been told CD length is 2 centimeter. CD length is 2 centimeter. So AD by 2, that is equal to BD. BD length will be, so here it is given BC length is 10 centimeter, which is given. So BC, so BD length will be BC minus CD. BC minus CD. So BC is 10 centimeter minus 2 centimeter. So that is 8 centimeter. So BD is 8 centimeter. So this is 8 centimeter, 8 by 80. So we can see that 80 into 80. So 80 square, that is equal to 2 into 8, which is 16. So 80 square is 16. So it means that 80 will be 4 centimeter. 80 length will be 4 centimeter. 4 centimeter is answer. And here also we have proved that a triangle ADB is similar to triangle CDE. And there is an OR part in this question number 22. In question 22 OR part, it is told to state and prove the basic proportionality. State and prove this BPT or basic proportionality theorem. State and prove basic proportionality theorem. State and prove basic proportionality theorem. Now here, basic proportionality theorem. So here it will be given that the basic proportionality theorem states that a line drawn parallel to one side of a triangle, it divides the other two sides proportionally. Divides the other two sides proportionally. So here you can draw one triangle. So here, let's say this is triangle ABC. This is DE. DE. You know, so from D we draw one perpendicular from AB from E also we draw one perpendicular from on AD. So let's say this point is M and N. This one is we will join. So here it is given that DE is parallel to BC, the triangle ABC, such that B is a point on AB and E is a point on AC. E is a point on AC. E is a point on AC. E is a point on AB and E is a point on AC. We have to prove that AD by BD is equal to AE by CE. This we have to prove. Now here we need one construction. Construction is that the line segments DC and BE are drawn and DN perpendicular to AC and EM perpendicular to AD are drawn. AD or AB, I can say EM perpendicular to AB are drawn. So now the proof is that you can say that the area of triangle ADE, that is equal to area of triangle ADE. You can say area of triangle ADE, that will be equal to half into base into height. So if I take AD as the base, then that will be into EM, and that will be also equal to half into base. If I take AE, then I have to take DN. Since we know that since area of a triangle is equal to half into base into height. Half into base into height. And now, similarly, you can say area of triangle ADC, area of triangle ADC, or I can say, sorry, area of triangle DEC. Okay, so area of triangle DEC, area of triangle DEC, I can say that is equal to half into base is EC into height, which is DN. And similarly, area of triangle EDB, that is equal to half into base is DB into height, which is EM. And here we can say that, and also we can say that area of triangle DEC, that is equal to area of triangle EDB. Since both triangles are on the same base DE and in between the same parallel lines DE and BC. Since both the triangles are lying on the same base, lying on the same base DE, and in between the same parallel lines, which are DE and BC. So hence their height is also same and their base is also same, so their areas should be also same. Now we can say that the area of triangle DEC divided by area of triangle ADB, that would be also equal to area of triangle EDB divided by area of triangle ADB. Area of triangle ADB. The DEC by ADB is equal to DEB by ADB. So now area of triangle DEC, can say it is half into EC into DM divided by area of triangle ADE, also I can say half into AE into DM. Half into AE into DM. That will be equal to area of triangle ADE. That is half into DB into EM. Half into DB into EM divided by area of triangle ADE. I can say that is half into AD into EM. Half into AE into DM, that is equal to half into AD into EM. So half into AD to EM, I can say. So now here we can see that half and half will get cancelled. And here DN and DN will get cancelled. Here also EM and EM will get cancelled. So from here we can see that EC by AD, that is equal to DB by AD. Or I can say that AD by BD, that is equal to AD by BD, that is equal to AE by EC. AE by C. AE by C. So hence proof. Now, in question number 23, it is told that triangle is a very popular shape. Triangle is a very popular shape used in interior designing. The picture given above shows triangle is a very popular shape used in interior designing. The picture given above shows a cabinet designed by a famous interior designer. So, designed by a famous interior designer. Here, the largest triangle is represented If the largest triangle is represented by triangle ABC and smallest one with shelf, smallest one with shelf is represented by triangle DEF. And PQ is parallel to EF. PQ is parallel to EF. Then the first part is being asked so that triangle DPQ similar to triangle DEF. Second is if DP equals to 50 centimeter and PE equals to 70 centimeter, then find PQ by EF and PQ by EF. PQ by EF, and then the third subpart A is asked if 2AB equals to 5 DU, 2AB equals to 5 DU, and triangle ABC is similar to triangle DEF, then show that perimeter of triangle ABC divided by perimeter of triangle DEF is constant. Or third subpart B, we told that if AM and TN are medians, if AM and TN are medians of triangles ADC and DEF, respectively, then prove that triangle ABM is similar to triangle DEM. So that now so here two triangles ABC and DEF. This is ABC and DEF. SPQ. AM is the median and PN also is the median. So this is triangle ABC, this is DEF. This PQ is parallel to EF is told, and here the largest triangle is represented by triangle ABC and the smallest one, which is shelf, is represented by DEF. PQ is parallel to EF. DPQ we have to show DPQ is similar to DEF. So now you can say that in triangle DEF, DP or PQ is parallel to EF, which is given. So I can say that this angle, these two angles are equal. Means that angle DPQ that is equal to angle DEF. Angle DPQ is equal to angle DEF. Since PQ is parallel to EF, since corresponding angles are equal, its corresponding angles are equal. Its corresponding angles are equal. PQ is parallel to EF. And we can say that angle D means angle PDQ is equal to angle PDF. Since angle D is the common angle, angle D is the common angle. Angle DPQ is, so hence I can say that triangle DPQ is similar to triangle DEF by angle rule, by angle similarity criterion, by AA similarity criterion. So hence proved is the first part has been proved. Then it is told if dp is equal to 50 and pe is equal to 70, and find pq by ef. dp is 50. dp second part, dp is given 50 centimeter and p is given as 70 centimeter. dp and p. So now we can say that dp by pe, that is okay. Now from here you can say that now okay. Now triangle DPQ is similar to triangle DAF, which is proved above. So I can say that DP by DE, that is equal to PQ by EF. Now PE has been given 70 centimeters. So now DE is equal to DP plus PE. DP plus PE. So I can say this would be 50 plus 70 centimeter, that is 120 centimeter, and dp has been given 50. So therefore I can say PQ by EF, and here the reason I can say dp by DE, that is equal to PQ by EF, which is also equal to DQ by DF. PQ by DF. The reason is since corresponding sides of similar triangles are proportional. So corresponding sides corresponding sides of similar triangles are proportional. So now I can say PQ by EF, that will be equal to dp by DE. dp is 50 centimeter divided by dp by DE base, which is 120 centimeter. So centimeter will get cancelled. 0 will get cancelled. So now therefore I can say PQ by EF, that would be equal to 5 by 12. So EF, which is equal to 5 by 12. So 5 by 20 is the answer for part 2. And in the third subpart A, it has been told if 2AB is equal to DE. So now here it is told triangle ABC. Now there is another triangle ABC and smaller triangle DEF. This is ABC. What is given that triangle ABC is similar to triangle DEF. And it is given 2AB. 2AB that is equal to 5D is given. Then we have to show, then we have to prove that perimeter of ABC, the perimeter of triangle ABC, which is AB plus, we have to prove that AB plus BC plus EA divided by the perimeter of triangle DEF is a constant. Now, perimeter of triangle DEF is the sum of all the three sides, that is DE plus BF plus FD. So that is a constant. We have to prove this. So therefore, now consider, since triangle ABC is similar to triangle DF, which is given, so therefore I can say AB by DE, that is equal to BC by EF, which is equal to AC by DF. Since corresponding sides of similar triangles are proportional. Since corresponding sides of similar corresponding sides of similar triangles are proportional. So now you can say that now AB by 2AB, that is given as 5D. So AB by DE, that is given as by D is given as 5 by 2. A by DE is given as 5 by 2. A by D is given as 5 by 2. So now I can say that AB, that is equal to 5 by 2 times DB. 5 by 2 times DB. So hence I can say AB by DE, that is equal to BC by DF, that is equal to AC by DF, that is also equal to 5 by 2. Since it has been proved earlier. So hence, so therefore we can say that this AB is equal to 5 by 2 D. So similarly, BC is equal to 5 by 2 EF, and AC also will be equal to 5 by 2 DF. So now we can say that the perimeter of triangle ABC divided by the perimeter of triangle DEF, that will be equal to AB plus BC plus CA divided by, this is DE plus EF plus DF. So that will be equal to, now AB is equal to 5 by 2 DE, BC is equal to 5 by 2 EF, and plus CA, that is equal to 5 by 2 DF. 5 by 2 DF divided by, that is equal to DE plus EF plus DF. DE plus EF plus DF. So this will be equal to, so 5 by 2 I can take as common from these three. 5 by 2 into GE plus EF plus DF divided by E plus EF plus DF. So then these two will get cancelled. So that is equal to 5 by 2. So which is a constant. So 5 by 2 is obviously a constant. So hence 2. Then in the third subpart B, that is given as AM and DM are medians of triangles ABC and triangle DEF respectively, then prove that triangle ABN is similar to triangle DA. then here it is given that ABC and DEF. So here AM is the median on BC and EN is the median on EM. So hence I can say that it's now we can say that EM proof we have to prove here. We have to prove that triangle ABM is similar to triangle DEM. It is given that triangle ABC is similar to triangle ABF. AM is the median on BC and EN is the median and DM is the median on EF, triangle DF. So we have to prove that we have to prove that we have to prove that triangle ABM is similar to triangle DM. So the proof will be given as triangle ABC similar to triangle DEF, which is given. So I can say that angle B that is equal to angle B, or I can say that angle ABM that is equal to angle BEM. Since the corresponding angles in similar triangles are equal, the corresponding angles similar triangles are equal. Similar triangles are equal. And I can say that AB by DE is equal to AC by DF, that is equal to BC by EF. since I can say, since corresponding sides, these corresponding sides of similar triangles are proportional. Corresponding sides of similar triangles are proportional. And also we can see that EM is equal to half of EC, and also EN is equal to half of EF. Since it is given that M is the midpoint of BC, since AM is the median on BC, so M should be obviously the midpoint of BC. And also N is the midpoint of EF, since it is given that DN is the midpoint, DN is the median on EF, so obviously N should be the midpoint of EF. N is the midpoint of EF, N is the midpoint of EF. So I can say that BC by EF, that will be also equal to half of BC by half of CS. So that would be equal to BN by EN also. So hence we can say that AB by BD, that will be equal to AC by DF. AC by DF, that will be also equal to EM by EN. So now, therefore, now I can tell that in triangle ABM, and triangle DEN, and triangle DEN, angle B is equal to angle B, which we have proved earlier, which we have proved above, and also AB by DE, that is equal to E by DE, that is equal to BM by EN, that is equal to BM by EN, which is also proved above. So hence I can say that triangle ABM similar to triangle DM. Triangle ABM is similar to triangle DM by SAS by SAS similarity rule, the SAS similarity criterion. SAS similarity criterion. SAS similarity criterion. So hence it is proved that ABM is similar to DNR. So hence proved. Hence proved. Then in question number 24, it is told that in an criterion. Okay, I'll start this at 5:30. Yeah. It's arranged. It's seats are arranged. Seats are arranged in rows and columns. Seats are arranged in rows and columns. The number of rows is equal to number of rows are equal to the number of seats. Number of rows are equal to the number of seats in each row. Number of seats in each row in the beginning. Then when the number of rows are doubled, and the number of rows are doubled, and the number of seats in each row, is reduced by 10. Reduced by 10. The total number of seats increases by 300. The total number of seats increases by 300. Then based on the above information, answer the following questions. Answer the following questions. Part A is given as taking x as the number of rows. X as the number of rows in the beginning. Represent the above situation. Represent the above situation by a quadratic equation. Represent the above situation by a quadratic equation. Then B part 1 it is given as how many rows are there in the original arrangement. How many rows are there in the original arrangement? Or in the or part it is given that the subpart 2 is how many seats are there. Many seats are there in the auditorium in the beginning. Many seats are there in the auditorium in the beginning. Then in C, part C it is given how many seats are there? How many seats are there in the auditorium after rearrangement? Now here you have to take it as x. X as the number of rows in the beginning. So the number of rows are equal to the number of seats in each row. The number of rows are doubled. The number of seats in each row is reduced by and the number of seats in each row is reduced by 10. The total number of seats increases by 300. So the number of rows are doubled. It means that 2x. So the new number of rows is 2x, and in each row we have x minus 10 seats, and that is equal to x squared plus 300 since the number of seats has increased. So x square was the total number of seats. Since here we have considered x is the number of rows in the beginning, so it means there were in the beginning, so it means there were x seats in each row also. So x square plus 300, so 2x square minus 20x equals to x square. 2x square minus 20x equals to x square plus 300. So I can say that x square minus 20x minus 300 equal to 0. So here I can say that x square minus 30x plus 10x minus 300, that is equal to 0. So here it means that the required quadratic equation is this one, x square minus 20x minus 300 equal to 0. So this is the answer. And then it is asked how many rows were there in the original arrangement. So it means value of x we have to find out. So if we solve it, then we will get therefore x square minus 30x plus 10x minus 300 equal to 0. It means that if we take x as common from the first two terms, then we will get x into x minus 30 plus 10 if we take as common from the next two terms, then we will get 10 into x minus 30 is equal to 0. We will get x plus 10 into x minus 30 equal to 0. So it means x is equal to minus 10 and 30, but number of seats can't be negative. The number of rows also cannot be negative. So therefore I can say x is equal to 30. It means therefore the number of rows is 30. B subpart 2. B subpart 2, it is asked that how many seats were there in the auditorium in the beginning. So therefore the number of seats in the beginning was x square, so that is equal to 30, that will be 900. So there were 900 seats in the original arrangement. And in the C part, it has been asked how many seats were there in the auditorium after rearrangement. So after rearrangement, of seats, number of seats will be equal to 900, will be equal to x square plus 300. So that will be equal to 900 plus 300. So that is equal to 1,200 terms. So hope all of you have understood the solutions of all these 24 questions. So any doubts that you have, please write that in the comments. We should obviously clarify them. So thank you everyone.